inequality pretty much the same as how we solve linear equations that we learned yesterday. But there's only one thing different. Okay, because it's an equal sign before, okay, it doesn't matter how you add or subtract or times or minus, you always have the equal sign there on both sides if you do this operation on both sides. But if it's an inequality sign, well, think about we have something, this part is a little bit heavier than this one. When you add things on both sides, this side will, well, add same weight on both sides. This side is still heavier than this one, right? So the inequality still remain the same. When you take some weight on both sides of the balance, you still maintain the same balance, like still heavier on this side. When you multiple that sometimes, so for example, we have 3 is heavier than 1. When you times 3 on both sides, 9 is still heavier than 3. So when you times a positive number, you still maintain this balance. But let's think about this. You have 3 greater than 1. When you times -1 on both sides, okay, you times -1 on both sides, we have -3 and -1 now. So let's think about -3 and -1, which one is larger? -1 is larger. So the sign actually swapped. Okay, the sign actually swapped. Now let's divide. Let's divide by, let's say divide by -2. What I have here is -1.5. And this side we have -0.5. Which one? Well, I'll write in fraction form. 3/2 and -1/2. Which one I think is larger? Larger. Which one? -1/2 is larger. So it will be a smaller sign. So what this example shows us is when you times or divide the negative number on both sides of an inequality, your inequality sign needs to swap. Okay, inequality sign needs to swap. So that's something we need to be careful with. Okay, that's something we need to be careful with. Other than that, it's pretty much the same as how we solve for equation. So let's have a look at the first one. If we treat this as an equal sign, okay, we treat this as an equal sign. What's the first thing we need to do? Good, get rid of the denominator. So what we should do to get rid of the denominator? Yeah, multiple both sides by 2. So when this is a positive 2, so nothing wrong with the inequality sign. We can do that definitely, and the sign will remain the same. So what we do is x minus 10 smaller or equals to 6. If it's an equal sign, what we will do? If that's equal, want to solve for x, what we will do? Plus 10 on both sides of the equation, because I want x on one side and then number on one side. So x will be less than or equals to 16. I can plus or minus numbers. There's no restriction. Even though I add a negative number, that's alright. It's same as you subtract a number on both sides. The inequality sign will still remain the same. It's not going to change. Okay, so I can add, doesn't matter what I add. But we need to be careful when we're trying to times or divide something. When we're trying to times or divide by something. Alright. Next one. Okay, next one. So we have t minus 4t plus 2. So there's no fraction. I can minus 2 on both sides first to get rid of the 2. So minus is okay. Okay, minus is fine. So nothing wrong with minus. So I have minus 4t less than or equals to 8. Well, if it's an equal sign, what you will do? Divide by minus 4. Good. Divide by minus 4. Okay. Now I want to divide by minus 4 on both sides of the equation. The sign needs to swap. Okay, the sign needs to swap. So all what I can write is minus 40 divided by minus 4, 8 divided by minus 4. The sign needs to swap. Okay, smaller equals 2 become larger or equals 2. Okay, smaller equals 2 become larger or equals 2. So simplify that. We have t is greater or equals to negative 2. Okay, greater or equals to negative 2. If we want to sketch this on the number line, okay, well, let's sketch it by a simple way. So that's x, this 0, and that's 16. What I have is x less than or equals to 16. We have a closed circle on 16 and all the way to the left. That's how we can represent the solution on the number line. Can you see we have infinitely many values which is possible for this inequality, because when it equals to 16 it works, when x equals to 0 it works, so there's many values it will work. This is called the set of solution. Okay, this is the set of solution. We have all the values less than or equals to negative 16 will satisfy this inequality. Okay, will satisfy this inequality. So if we want to put that on the number line, we have 0 here, we have negative 2 here. We want greater or equals to negative 2, which just looks like this. It just looks like this. Okay, next one. If this is equal in equation, what we will do? Cross multiply. Good. Okay, we can do cross multiply if that's an equal sign. But there's a problem for inequality to do that. Okay, that's what I want to say. Why we can't do cross multiplication? Can you tell me a reason? Well, I'll tell you we can't do cross multiplication here. But why we can't do it? Kind of they're not the same. Or it's the inequality sign. Okay, one side needs to be larger than the other side. So when you cross multiply them, which one you put on the larger side and which one you put on the smaller side, you can't decide that, right? When it's equal sign, it doesn't matter, this one equals to that one. But when you have inequality, well, is that this times that on the left hand side or this times that on the left hand side? That will make a difference. Okay, that make a difference. So that's why we can't use cross multiplication in the inequality. I can't decide which one to put on which side. Well, this one put on left hand side or right hand side, smaller or larger, I can't decide. So except except cross multiplication, what we should do? Same denominator. What's the same denominator? 15. Therefore we can times 15, well, a positive number, which is all good, times 15 on both sides of the equation. Okay, we can times 15 to get rid of the denominator. What I want to do is get rid of the denominator, not make a same denominator. If you times 5, you can't get rid of the 3 on that side. If you times 3, you can't get rid of the 5 on the side. So you need a number contain 5 and contain 3 to get rid of it. Okay, so this 5 will become a 1. The 15 become a 3. This 3 become a 1. This 15 become a 5. So what we have here is a 3 times, well, that's a 6. So 6 times 4 minus 3x larger than 10 times 1 plus x. Which one? You can't decide which one go on which side. If you go cross multiplication, this one can go on that side. Well, which one you multiply? Well, which side? How do you decide which one is facing? For example, I'm doing, it's the same. It's only the sign. You can't decide the side. Which side you put the greater? Well, I can do, for example, cross multiplication. I can do those two cross first to put on left hand side. That will give me what I have now. But I can also cross multiply this first and put on the left hand side. Why you can make sure? Like you can't make sure. Why? It's not really that simple to always put that on the left hand side. You will, like the sign. If it's x greater than 2, then you have x less than 2 if you put on the wrong side. So you can't make sure like which side is going. So that's why I said you get rid of the denominator, but times the same thing. Well, cross multiplication itself is actually the same as get rid of the denominator. It's just like we skip some step in between. So inequality is hard to decide which one is the larger, which one is the smaller. So that's why we just use times 15. So we have 24 minus 18x on that side, larger than 10 plus 10x on this side. If we want to keep a positive x in order to divide a positive number, what we can do is add 18x on both sides. And then minus 10 on both sides. You can add 18x but minus 10 at the same time. So what we left with on this side is a 14 greater than 18x. 28x. And we can divide by 28, which is a positive number. Okay, which is a positive number. So I don't need to swap the sign. Okay, I don't need to swap the sign. So x is less than half. X is less than a half. Okay, x is facing the smaller side. So x is less than a half. So if you sketch this on the number line, less than half, but can't take a half, so it will be an open circle. Okay, it will be an open circle on the end point. It can be a little bit smaller than a half, but not going to take the value of a half. You can take it or you can't take that point. Like a half, you can't take a half because it's x less than a half. X not going to equals to half. Yes? But this one, t can be greater or equals to negative 2. You can take negative 2. Well, also, that's not x. That's a t-axis. That's a t-axis. That's x. Well, when something you can't take, but you want a starting point, what do you start with? You start with a half. So you put open circle there. So any value, even though a little bit less than half will work, but not the value of a half. So it depends on whether you have greater or equals to or smaller or equals to, that's a closed circle. But if you have greater or smaller, you will have an open circle when you sketch the number line. Okay, I'm not going to do the next three. This question is a good question. You can think about this one. Okay, you can think about that one. It's a really good question. I'll skip that. We don't have enough time. So I want to go to the next question here. Okay, let's have a look at this question. The width of a rectangular area is 10. The area is 10 meters and its height is, okay. The width of rectangular is 10 meters and the height is 2x minus 4. Let's sketch that rectangular. Well, it can be any rectangular. So we have a width of 10 meters and with a height as 2x minus 4 meters. And if the area is less than 80 meters squared. So that's my area. Well, it can vary. Like I want area less than 80 meters squared. What are the possible integer values for x? Okay, what are the possible integer values for x? Let's have a look at this question. What kind of inequality you can set up? What you can do? X minus 4. Okay, less than 80. Let's solve for it. Okay, let's solve for it. First of all, we can divide 10 on both sides, right? A positive number, divide 10 on both sides. We have 2x minus 4 less than 8. It's a positive number, so nothing wrong. And I can add a 4 on both sides. So that's 2x less than 12. Add 4 on both sides. And then divide that 2. So it's all positive, so it's all good. So divide 2 on both sides. We have x less than 6. So what's your answer? Well, x less than 6. Well, let's think about that. Just purely see from your answer. Your answer is x less than 6. Is negative 1 less than 6? But why you don't take it? Yeah, negative 1 is still integer. No, negative integer. Okay, so if you say you can't take a negative value for like a shape, like a graph, can you take 1? Really? If you put 1, that becomes negative 2. That. So we have a restriction on the height as well. If you sub 2, what that becomes? 0. We can't take it. We have another restriction, which is 2x minus 4 needs to be greater than 0 as well. Because when x varies, there's a possibility your height is not a positive number anymore. So you need to restrict that into a positive value as well. So what I have here is 2x greater than 4 and x greater than 2. So you need x at the same time to be greater than 2 as well. So what's the possible solution here? X can only be 3, 4, and 5. It's not really what your x can take. It's the x can make your height or width become what? Okay, it's not really the value of x. It's about the meaning of the height and the meaning of the area. So even though the question didn't say anything about the height, you need to know that your height needs to be greater than 0. So that's some, yes? If you sub 1 into the function, 2x minus 4 is what? It's negative. You have a negative height. Yeah, this is a really good question. It's quite interesting because we need 2 inequalities to restrict the x. We need 2 inequalities to restrict the x. Because 1 is not enough. If you just say x is less than 6, it can be 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. It can be forever, like infinite many values. We need another boundary to keep the value like in between something. Yeah, that's how you write it. Because x needs to be larger than 2 and also needs to be less than 6. So x is in between 2 and 6. So what's the value in between integers? So 3, 4, and 5. That's how you show it. It's not really by try and error. Think about if you have something like really large and hard to try. How many times you need to try it? It's very hard, very difficult. So what I recommend is 2 inequalities there to show. That's actually how you should work on this question, not really by trial and error. Alright. Any other questions about this one? So we have inequality 1 and inequality 2. Alright, example 3. Example 3. Describe the sets in the form like x is in between something. Can you see that's in between? X is larger than 2 but less than 3. Okay, larger than 2 but less than 3. Ask you a question. Can I write this? Why not? That's right. That's something like won't happen. You can't have a value greater than 3 but less than 2. Okay, so this one means x greater than 3. And then this part means x is less than 2. You don't have those values. So that's not working. So what we can see here is x less than 5. What I want you to do is show that on number line but by using different colors. This is a very important skill. So we have a number line, x. We have the value, okay, what value has been mentioned, which is 4 and 5. What I need is x less than 5. I use a blue color to sketch that. Is all the value here. And I want x greater or equals to 4. I have a closed circle here. There. Can you see what is the x in, what part of x is in both sets? Can you see where is it? 4, 2, 5. Is the area where you get two colors, right? You get two colors. But is that 4 a common value? Is 4 a common value? Like in both sets. Is 5 a common value? No, because it's open circle on the blue one. So 5 is not in the first set, but it's in the second set. So it's not something common. So what I should write here is 4 smaller or equals to x less than 5. You can't equals to 5. The x won't take 5. The x will only take 4. And then any value in between 4 and 5. Questions? Okay, therefore for the next one we have negative 9.5 and a positive 7. First one wants smaller or equals to 7, which is all the way here. Second one wants greater than negative 9.5, which is this part. What we can see in between is in between negative 9.5 to 7. But negative 9.5 is not in both sets. So my answer will be negative 9.5 smaller than x and smaller or equals to 7. Okay, last one, C. Can you tell me what's in common? Something less than or equals to 10 and something greater than 10. So in common is only 10. So what we should write is 10. X equals to 10. Well, if you write that, you can obviously see that 10 is the only possible value. Right? 10 is the only possible value in this set. Well, x is greater or equals to 10 and less than or equals to 10. So 10 is the only value. So we write x equals to 10 for this one. Alright. For the next question, can you see A, B, C, D? They are in the same type. A, B, C, D, they are the same type. Why they are the same type? Because you have two inequalities. Can you see two inequalities? Like something's in between something and something. So what we should do to this one is we operate things all together. Okay, we operate things all together. So for example, the first one, I want X in the middle. I just want X in the middle. So what I can do is add 2 on everything. We add 2 on every side. Okay, every single term. So what I have here is 3 less than equals to X less than or equals to 9. So X is in between 3 and 9. Okay, X is in between 3 and 9. But if we look at a harder one, let's look at D. Let's look at D. I don't want to remove the X. Okay, I want my X stay in the middle. So I want to remove the constant. So can you tell me a way to remove the constant for this one? What I should do to remove the constant in the middle? No, the constant. That's the constant. Minus 5. Good. Take 5. So we take 5 on everything. So we have minus 7.5 less than minus 2x and minus 2. What I should do next? Okay, when you divide by negative 2, what will happen? All the sign needs to flip. So it's negative 7.5 divided by negative 2. Minus 2x divided by minus 2. And minus 2 divided by minus 2. All the sign needs to flip. So this sign become a greater. This sign become a greater or equals to. Because we divide negative 2 on everything. Okay, we divide negative 2 on everything. So sign needs to flip. So what we have here is 3.75 greater than x greater equals to 1. So it's better to write the smaller number on the left hand side. So it's 1 smaller equals to x, smaller equals to 3.75. E and F belongs to one type. E and F is still the same, like you have one inequality sign. Okay, you only have one inequality sign. So let's do E. If that's an equal sign, what you will do? You can't cross multiply because it's two fractions on left hand side. Denominator, so what's the lowest common factor for all the multiple, I mean? 6. Right? 6. So I will times 6 on everything. Everything, okay? I mean this. And then times 6. So what I can do is that's 6 times 7x minus 1 over 6 minus 6 times 2x minus 1 over 2, and then that's smaller equals to 3. What I have here is the 6 and 6 will get cancelled here. But this become a 1, that become a 3. So is 7x minus 1 minus 3 times bracket 2x minus 1 less than or equals to 3. Do not expand it directly. Let's put the bracket there because make sure all the signs correct. So have 7x minus 1 minus 6x and then plus 3 equals to 3. So on this side we have x plus 2 less than or equals to 3. Then x will less than or equals to 1. We minus 2 on both sides. Okay, be careful, there's a plus. Okay, do not hurry to expand it on the second line. If you expand there, you may get a minus 3 there. So just make sure everything's correct. We'll do one last example here. What do you think I need to do first? So how I can get rid of the denominator? By 20. Good. So we'll multiply everything by 20. So we have 20 times 3 minus x over 5 plus 20 times 1 plus x over 4 greater than 40. Greater than 40. So we have that becomes a 4. That's a 1. That becomes a 5. That's a 1. So 4 times 3 minus x plus 5 times 1 plus x. That's greater than 40. That's a 12 minus 4x plus 5 plus a 5x greater than 40. Simplify it. That's x plus 17 greater than 40. So x is greater than minus 17 on both sides. 23. Any questions? Okay. If you don't have any questions, like we have done this exercise, so finish B, C, and the 3 questions are both like we have 5 more minutes. No, we have more than 5. We have 7 minutes. So you can finish that. Okay, do those questions.